Sharang, you are not audible. You are. Can you unmute yourself?
Yeah, sorry, I forgot. Okay, okay. So this was what was um, shown in the last class. I wanted to show how to handle the problem, but I kept ignoring these constant terms. One is here, like, that translates to this term. Then again, this constant term comes. So these will remain, and after uh, arranging the other terms, like these two terms were the more complicated ones. I was trying to show how these two combine to give a form such as this AS, ALO. You can combine, and the E raised to power J something something term will form this kind of a form and collapse into a cos term. So the whole complicated expression becomes this part. But I ignored the constant terms, this AS square, ALO square. So when the assignment asks for when the assignment asks for photocurrent I1, the answer is not just this RD term. It also contains these two constant terms, right? The DC terms, A square plus ALO square, that I completely ignored. So that is how the mistake was made. So I don't know if I should take the responsibility that you made the mistake because of me. But it is clearly asking for the I1 photocurrent. I mean, that was a mistake from my side. It was a cleaner version of the same thing. Again, these terms are ignored. So I only said this AC component of I1. What was asked was entirety of I1. Anyway, yeah, second question was also a copy. So did you get the rest of the expression? Like you got to the that expression, so you know how to arrive there, right? And what you missed. Yeah. And the concept is there. You made some silly mistake. That's it. Yeah. Don't worry about it. Uh, let's start with a brief overview of what was done this week. So we started. We just touched upon this optical networking concepts. Basically, we drew some pictures. That's all, and a lot of information was there. Uh, Try to remember some of them. Just remember the concepts because these standards are evolving quite fast, as also mentioned in class. So we started with a brief discussion about network structure, like how core network, metro network, how they connect. I think that was also the point. How we started the whole course, and that was the image we started the course with, right? Then uh, we talked about OSI model, which is widely used in uh, a lot of applications. So how uh, one application communicates to another application in some other computer, how that happens. That was shown in this OSI model. and entirety of our course was mostly focused on the physical layer. So where we are transmitting bits using the electric fields and electric field intensities and bits and symbols, all those. So in OSI model, layer two is this data link layer. We talked about how it handles our data, how data is transmitted. So this concept of this header and trailer was introduced. Trailers are uh, I have not seen too many like trailers like 4G, 5G also uses only header and packet kind of structure. And because optical fibers have a lot of bandwidth, so there is a point in departing from the OSI model and what kind of standards we use. Those were discussed in this SONET for North America, SDH for us, Indian networks. Then we discussed briefly how the frame is structured, uh, what the standards are called, and all those, and how this. Uh, we showed the diagram how sections and lines and everything uh, are laid out, and what information we need to include on top of our data to make sure that our data goes to the correct place. So, um, by the way, in the lectures we mentioned this rows and columns. We never said what rows mean. Basically, everything is transmitted row by row in that one frame. So it will transmit this all of the columns of row one, then row two, then row three serially. It will transmit. Then we discussed about this the different kinds of networks like access network, which is basically servicing the end users, then interconnection between metros, which is metro network, then wide area network, global network we touched, and then what kind of different network topologies can be possible, that we discussed one by one, like point to point, like president to president, then bus connection, star connection, ring, then dual ring. We also discussed a little bit more detail later on also. Then mesh connection, which is very resilient but also very expensive, and then tree topologies, which are common in data centers. And so, and then we discussed one example for this bus topology. Uh, then this how this reliability of the network can be ensured, what kind of uh, topology to use. So we took two examples. One was UPSR, one was DLSR. Uh, then we talked a little bit about this passive optical networks, which are usually what you see at your home, right? So you won't have any amplifiers and all. So the optical network is passive. And but like when you say passive optical network, you usually mean the last mile uh, optical fibers. So so we discussed three configurations of passive optical networks, like direct fiber connection, time division multiplexed uh, passive optical network, and wavelength division multiplexed, which is still rare, I think. And then we briefly touched upon the standards for these passive optical networks. This is GPON is the term you will hear most commonly because this is the most common right now. Then we talked about other applications of this, uh, where all this while we were taking the example of delivering data to someone's home, right? But optical networks can also be used for other uses. We took this example of optical interconnects in a data center, and then we also gave the example of how wireless networks also use optical connections. Wireless front haul is the connection from the tower to like base station to a central hub. So this terms like CDN, Cloud RAN, you will see it repeated again and again in any 5G literature if you read, and standard CPRI was introduced, and how uh, there is a demand for ever increasing capacity for optical networks that was mentioned, and that's how we ended the course. So most of the course was focused on physical layer, like how uh, the fiber behaves, how we have how to make these optical transmitters, receivers, and how to transmit data, how to modulate the optical signal. So all those were discussed, and we ended with this optical networking concepts because you need to know where this puzzle piece fits in the wider picture. So that is how we end this course.
Anyone have any doubt from week 1 to week 12 regarding exam, regarding course content, regarding assignment, quiz? Akansa, are you there? Namita, Jonek, can you do unsharing? Stop sharing.
I stopped sharing.
Why my screen is not visible?
Yes, it's visible.
So, should I continue?
Yes, yes.
Anyone have any doubt regarding MATLAB or anything? Because we have the last class today. After that, we can reply on your email on that ask to question form only that. So, what we have to do in the optical communication system? Anyone can tell that? What do you understand by the optical communication system? Or can we stabilize a connectivity of large number of users through the optical communication network or not? So, as you seen that in the figure that we have the wireless access network, metro network, edge cloud system, core network in the system. We have to connect through the data center where we can transfer of the data. Have you seen in that industry or any academic there is one data center where some data will be stored or transfer of the data will be take place. There is one cloud system where we have to store our data like Google Cloud, Microsoft Cloud system. There is a metro city through which we connect the network that wireless connection, wired connections, that always all the system are using that optical network or optical fiber or optical component, that is either active or passive component. So Jagannath, are you there?
Yes, sir. Yes, sir.
So What do you think about that? Why we should we go for the optical network? We can use for that electrical network or analog network, digital network. Any advantage over this, or what is the properties we need to make that connection of the optical network in the metro, local area network, or metro city like that? India have now plan to the national knowledge, national network knowledge center (NKN) center will be developed in every academic or that industry. Through that, everything will be connected through the NKN. So, what is the properties and advantage of that?
But actually, in optical communication system, the bandwidth is very much high, and it can help in longer transmission distance. And fiber optics have much greater bandwidth, which access metal cable. It is most suitable for transmission of data, and there is less noise also,
Okay.
and stronger security and latency.
Okay, okay. So, what is the desirable properties that if we want to stabilize well, like optical network in any academic like that, any academic institute or technology institute or any college or school? So, what will be desirable properties that we have to stabilize that optical network in that? What we have to think about that this property will be needed for that optical network to stabilizement. Namita?
Actually,
So the main property is high throughput we require and high latency is required. It is a desirable properties of optical network.
So anyone have seen that data center? Anyone go to their college data center? There is a rack and there is a light will be blinking and optical cable, that LAN cable will be connected. Anyone have seen that? Have you personally experienced practical experience like that? In bank or everywhere there is a like that. Have you seen like that? Have any about that practical experience that?
network capacity per second. And
Like
in
that, have you
total,
any
that's
see like that
1.6
optical network in the system?
terabits
That this
of
is a
zeros and
Google.
ones.
Fiber, the
Of zeros and ones.
So I had seen in
that
BSNL
increased
office like
capacity
this
is to
setup.
squeeze more fiber pairs into a cable. In 2020, we were able to fit 16 fiber pairs into the Grace Hopper cable
Now
instead of the
latest
usual
technology
6
will
or
like
8.
that only.
That cable can transmit 340 terabits of data per second, enough to stream this video in 4K 4.5 million times simultaneously. But it's not just about capacity. Building a cable takes a village, and we
but
work
actually,
closely
it
with
is
many
based on
partners.
the total internal reflection.
Yeah, yeah.
Their
But they
local
have set up
infra
like how
to
that fiber will be
facilitate our
set up
cable
and that
landings.
industry that this
We
in the
want to
sea.
carefully ensure minimal interruptions to local communities, such as
This
fishery
is that
union and
optical fiber under the
marine
sea.
life heritages, etc., where we are constructing those cables.
One of the final steps to laying a new cable is making sure we have the most up-to-date electronics in place to power it. And we've made some impressive enhancements to Topaz. A wavelength selective switch for resilient and dynamic paths was first sketched on a Google whiteboard over 4 years ago. Now this innovation is being implemented in Topaz and adopted across the industry.
In the very early days of cable with simple point, the wavelength selective switch allows us to effectively carve up the spectrum on an optical fiber pair. Use some
See
for
that
this
how that
purpose,
optical
use some
wavelength
for
or
another
selective switch
purpose,
WSS will
in
be
order
work.
to expand the capability. End users benefit from our ability to redirect traffic on the fly.
So if a new customer demands more capacity, we can run commands from a computer and traffic shows up quickly in a different place. Pretty powerful, right?
A cable like Topaz doesn't just improve reliability between Canada and Japan, it improves reliability like a mesh. Our organization focuses on creating solutions that interconnect humanity, and that's really the purpose of our network. Our highest priority is to create a network that society can depend on.
It all comes together on a momentous day at shore. Teams all over the world collaborate to stretch our network fabric through an enormous feat of partnership, physics, and engineering. It's our network that makes Google Cloud ready for the next wave.
See that how optical fiber.
Regions. To create connections between machines, then expands to connect to other data centers in the region. Long-haul cables sometimes span mountain ranges to connect far-flung regions. To create connections between continents, our subsea cables are carefully laid on the ocean floor. Let's take Topaz, one of our newest subsea cables. Canada to Asia. Its planning started over 5 years ago. Predicting capacity and building a cable isn't easy. I got to meet the teams that made it happen.
The current would be say, appetite for like by adding more diversity.
So Google Cloud has become a big part.
Obviously, replicate optic spools that are about 80 kilometers long, and we actually daisy chain these fiber optic spools together
So have
to
you
try
seen
to
like that?
replicate a Google Cloud.
Anyone have experience like that? So this type of the network we have stabilized between that our cloud system or metro network or wireless network. So what is the advantage of that optical network? High speed capability. It is around 50 Gbps. Terabytes per second using that 50 terabytes per second using a single fiber. Low signal attenuation loss will be low in that dB per kilometer. Per dB per kilometer loss will be less. Low signal distortion that Jagannath said, well, the noise will be very less in that case. Low power requirement, it will be operating under low power like that 1 volt, 2 volt, 3 volt power supply. Low material uses, small space requirement for that. If you use that conventional cable or that like that poles and system that copper and that they have to require more space in that case. Low cost. So this is the advantage of the optical network over conventional network system. Immunity to electrical interfaces, because there is a clouding of the surrounding of that optical fiber, so external environment atmosphere effect will be zero, in that case negligible. So what is the desirable properties to establishment optical network is the large number of users. If we can make the optical network, in that case there is a large number of users. If there is a very less number of users like the 10 or 20, it will not feasible, it will be very high cost in that case. Efficiency, flexibility of the resources. Low probability of jam, blocking should be not there in that case. Large capacity to be available user, high reliability of that. Means if any people want that 100 Gbps speed or 200 Gbps 10 terabyte, that capacity will be available for user in that case. So what can you tell me the type of switching in the network?
So the question which arises in the exam, be
Yeah,
theoretical something or not? There
maybe
may
it
be
will be
theoretical
it will
question.
be theoretical numerical, both type will become that.
Okay.
In your lecture it will be everything will become that like that. If anyone want that name the two type of the switching in network, type of the path that signal can possible in the network, that physical layer, attenuation you have to calculate, numerical aperture you want to calculate, what is the passive network, about how to laser will be, which principle will be laser will be work, that power of the laser how to calculate, responsivity how to calculate, a photo detector side your receiver, noise signal to noise ratio you have to calculate. So it will be like that. Based on that, whatever the assignment you have to done, it will be nearby that only. That have you solved that assignment problem, like that problem will become in your that exam like that. It will be mix
Okay,
of
sir.
that some basic understanding of that topic and some numerical understanding of that. Okay.
Okay, sir.
So next question is the type of the switching in a network. So we have the two type of the switching in a network. One is the circuit switching and another is the pocket switching. So circuit switching is defined as a method of switching which used to establish dedication communicate path with the sender and receiver. This diagram is that. So what is, there is a three terminal. This is visible diagram. This is a terminal 1,
Yes, sir, visible, sir.
terminal 2 and terminal 3. Like that I, Jagannath and that Namita will be connected through that, like that I am here for one in terminal, Jagannath and Namita will be on terminal 4 and 5, and I want to send some data like that. We have to speak and some data will be received to you. So it will some take dedicated path. This is the switch. This may be that this is switch will be depend upon a topology of data. How this will be arranged, that ring, match, point to point communications, logical communications, bus topology, tree topology. So it will be assigned that network like that, how much where to you have to communicate data. So that if that terminal 1 go to that data through that this switch, and this will become through that path, this will be connected and this will become like that. If second one want to send, it will become to this and this one. If it want to send, it will directly switch 3 to connect to link 3. So it will take the path, shortest path will be taken by that data. Okay, whatever the shortest path will be that data will be go through that, because it will take less time to that through the shortest path, and it will have the less losses in that link design. During that, couple of losses and switch losses and everything will be less in that case. So the link which is stabilized between the sender and receiver is the physical form. So it will be like that, not the wireless form. Optical signal will be moved in that case, like that optical fiber or will be there, that in case. An analog telephone network is well known example of the switching, circuit switching. Have you used that analog telephone? Anyone? Have you seen?
Yes.
In your offices, and there will be like that, there is a intercom. So what is happened that you have to connect through that wire to wire through that, from one office to second office, and that. Have you used that services in offices or that in industry, anything? Anyone? Namita? Maybe your college will be there in the.
So I had seen in BSNL office about all this.
Yeah, BSNL office will be there. Like that, before that we have the BSNL that tower will be there, that some, and the network will be come, and we have to call through that dialing number and that. So it will be connected through that point to point communication will be there in that case.
So earlier EP, BX machines are using earlier.
Yes, yes.
Electronic private automatic branch exchange.
Yes, yes. So bandwidth is in fixed this type of network. So what is happen? The bandwidth will be user will be fixed in that case. Like that, I have to set this is the point to point communications, and if this bandwidth will be utilized only by the one user. If I want to second user want to communicate that data, it will be not take. So this time will be fixed for particular users. So at a time one user can use that bandwidth, so whole bandwidth will be occupied for the one user. So multiple user will be not take place the communication through that circuit switching. Okay, because if this both terminal want to work, so this switch will be busy. If anyone that this switch will be in between, and it will be work for the user for one at time, particular one time. So first it will complete that data, and then he will send that data for particular time. So this is the advantage, the maybe disadvantage of that circuit switching is that. So advantage, the bandwidth use is fixed, the quantity of communication is increased, the rate at which data is transmitted is fixed, so we cannot change the data. While switching, no time is wasted in waiting, because we have to allocated particular time for particular bandwidth for one user only. That it is preferred when communication is long and continuous. So if you want to not to disturbance in the communications, you want to make the communication like that, uh, in the now there is intercom used in that building in the industry, or there some system. So they are communicate through the optical network from one to one, and this will be long communication, no disturbance in that case. Disadvantage, since dedicated channel are used, the bandwidth requirement is more, the utilization of resources is not full, because one at one time particular one user can use that resources. So it will be wastage for the whole resources, because bandwidth is requirement is more in that case. Since a dedicated channel has been used, the transmission of the other data become impossible. So if you want to transmit another data like that, if you use the audio call, and meanwhile you want to do it video call, it will not possible in that case. Circuit switching, you can do only that audio call at a time, particular time. Or you cannot use that email, you want to send that email to data while the calling, it will not possible. When your call will be cut, then you can send the email to that persons. The time taken by the two stations for the establishment physical link is too long, because if one user will be not that disconnected that call, or that bandwidth will be not that fixed at that particular time, you cannot connect that call to. So it will tell that a person will be on another call, another call, or another call, or something that. Circuit switching is an expensive, because every like that you need every time a line here and here and here, so it will be like more uh, network in that case. This is another is the packet switching. See, like that data will be sent in the packet. So this is my packet. It is visible. So
Yes, yes, please.
Yes, sir. Yes, sir.
so this is the part. This first portion will be header in the packet, and second will be this is the data you have to send. So header, what will be header will be do, it will be tell you about that address, and that where want to receive, what is the data type, and everything information will be contained in the header. Okay, so what is the data type, where it will become, which is data, what form of is data, that will be contained in header. And another that the actual value of data will be contained in the packet. So it will be divided into 1 2 3. So first will we go to that header, will be this this header, this data will become by one. So what is happen that, like that four data, this 1 2 3 4, there is a 4 packet in that from terminal will. Suppose that 3 and 4 will be coming through this, and 1 will be coming through this. So parallelly data will be go through that terminal 2. Okay, but in case of the circuit switching, you can send at a time one data. You can parallelly will be not send you data. So what happen that 3 and 4 will be, that data will be received at a time, that 4 data will be received at the terminal switch 5. So the so user will be receive all the data at a time. So bandwidth will be not fixed in that time. So it will be a time will be a particular time will be allocated for the particular pocket in that case. Whole bandwidth will be not fixed for the whole time that in that case. So each packet will be routed from source to destination as an individual packet. You can see that 3 and 4, 1 or 2, you can send 1 and 2, 3 and 4. When the packet arrives at the destination, it is responsibility of destination to put this packet in the arranging order. So there will be one, that receiver side will be that communications channel will be that arrange that all that data in that ascending form or descending form. Whatever the first data will be, that will be code that signal, that whatever the transmitted data will be, the encoding will be coding will be there in that, decoding will be there in that case, the receiver side. So what is the advantage of there? There is no delay in the delivery of the packet. So at a time you can send more number of packet or more number of data. There is no requirement of the massive storage space, because the bandwidth will be in the less requirement is the bandwidth will be same in that case. Failure in the link does not stop the delivery of data, as the packet cannot be routed from the path 2. So failure of that data, if this link will be fairly, then we can send whole the data will be sent in that case from that. But in that circuit switching, if any link will be failing, or it will be distortion in the link, then whole the data will be stopped. We cannot send data, or our phone will be discontinued, or email will be discontinued. But in case of the packet switching, we can, if the one link will be destroyed, we can send through the another link. Disadvantage, installation cost of it is very expensive. In that case, the delivery of this packet become easy when complicated protocol are used. High quality voice cannot be packed. Connectivity issue, because loss of the information in the delivery. But in case of the circuit switching, it will be not happen. Any doubt in that case? Have you any questions? Anyone have any doubt?
This is clear, sir.
So which layer is act bridge between software and hardware implementation of? Have you in the network layer, have you studied about the network layer in the network, or any communication in BTech, MTech, about which type of layer will be in that?
OSI reference model, so we are using physical data
So
link network.
how many of layer will be that type of?
Seven layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer.
So which layer will be used between software and hardware implementation of the
So,
optical?
physical layer.
Physical layer will be between that network and that. We have the
So,
seven.
application layer. Application layer.
No. Application is the software
Sir,
part.
it is data link layer.
Application is like that. There is a three layer. There is application layer.
Sir, it's
That is
data link layer.
software. Yes, data link layer. So what is the data link layer? That can you explain that what is the happen in the physical layer or that data link or network layer? Anyone can explain what you mean by that physical layer, data link layer, software layer, application layer? So have you in which layer a optical fiber classify an optical OIC modern network layer? Where we use that
Physical layers.
physical layer? Okay. And what is the additional layer we use in optical network? Remaining that network
It's
layer.
client layers.
What is the role of the client layer?
Sir, it has SDH and SONET
What?
network.
Sri, Asita, tell again. Can you speak pattern again? Yeah, you are right.
It aggregates and deaggregates the low level layers, like
Okay,
low level networks.
okay. So data link layer. These are the layers. Have you? These are the seven layers we use in that case. So optical fiber cable we use the physical layers because we want to transmit data from like that from our system like that we if anyone want to email to me, okay, so how email will become to me? Suppose that you have any doubt or you have to write some email from your laptop or computer and that will to receive to me, so how it will be received to me that data? Some medium will be there, some network will be there in that case. So what is happen that your system, that your computer or laptop will be connected through the optical fiber, that cables like that some like we have the wireless communication here for the data, okay. So that router will be connected through the optical fiber. There will be some inside that there is a network layer or that data link layer, the transport system will be there in that or you can see that data center will be there. So that data center will be hold all the data or that address will be there, so where it want to send or it will be to receiver and transmit data will be there. These session layer and presentation and application layer are called the software. These are combined all the called the software, and these three are called the hardware. And transportation layer will be that transport medium will be there, that anything between that this hardware and software that. So have you heard about that SONET or SDS? Anyone have heard the name of what is the full form of SONET and SDS? Arshita?
Sir, SONET is
Yes, sir.
synchronous optical
Synchronous
network.
data,
Optical network.
One by one. Yes, what is Arshita?
synchronous digital high res.
It is SDS.
Yes, sir.
And what is SONET?
Synchronous optical
SONET
network.
synchronous optical network.
So where will we use the SONET and where will we use the SDS? India will be use the SDS or SONET?
SDH, sir.
SDS. And SONET will be where used? Which country use the SONET?
North America, I think. North America.
United America. America will be used that or Europe and Asia and every use the
North
SD.
Africa.
Yes.
North
So
Africa.
this is the that you have seen that this is the block diagram architecture of that. What is the STS and that? How do you represent that SONET and SDS? Have you remember that STM1 and STS 1.0 and 2.0, 3.0? Have you heard about that? If you read that
Yes,
SONET,
sir.
that SONET signal that transmission data rate of SONET and SDS. How can you represent that? Have you looked at STM1? STM1 for 16, 64, 256 and STS1. Have you remember that STS1, STS3 and that? Anyone? So how you calculate that bit data rate, that data rate of that ST and STM? So we have that 90. This is the that in STS architecture we have the 90 rows. These are like that 90 rows. These are all the 90 rows, 0 to 89s. That column is the 90s and 9 row. These are the 9 rows. So I have distributed that application, that management of that. This is that, and this is the data where we can load a data path here. Users data will be loaded from that. After that 3 row, that 87 column will be user by 87 and 90 user data and path overhead by that. Means this data, all the users data will be saved in the 90 rows into 83 column, and this that blue line will be line overhead, and this yellow line will be section overhead. So in the section overhead we have the A1, A2, C1, B1, E2. So that A1, A2 will be alignment of the data. So like that address and everything, that header I have said, that packet switching, we have the header and that everything. So B1 will be a parity byte of that section. C1 is the identification, how to we identify that which data, that it is my data, that is Harshita data or Namita data. D2 will be management of that data, everything. E1 will be ordered byte, that byte will be sent, that will be done by the order, and F1 will be for the users, for particular users. This H1, B2, D4, that you have to see that H1, H2 will be a pointer. So pointer means where you have to send the data, which palace. So this will be point that data. Okay, I want to send to the Harshita and that Jonak and that Namita and that Jagannath, where to that point. B2 will be that line parity bit. So there will be that data parity bit for that data, that 0 and 1, that and which line will be table, that connected line, there is some parity bit of the line also. D4 and D12 will again do the management of that byte of that data. E2 again that order wise by byte, that even in the that section order and that line we have to again to order that data, so it will manage by in the E2. K1, K2 automatic protection of the switch, that that data will be lost, will be not lost, it will be protected through that some uh, packet will be protected, so no one will, users will be destroy that and store that data. And Z1, Z2 will be the growth bytes. So how you calculate that STS1 data rate, STS3 data rate, STS5 data rate, or STM data rate? I have given to you questions. Can you calculate that? Anyone? If it will be wrong, it is okay. But have you anyone tried that? Any idea about how to calculate data rate of that? So STS data rate will be we calculate. This is the like that I signal send 8,000 frame per second signal send, means per second I have sent to 8,000 signal in the line. So total my user data should be 8,000. Each STS1 frame is made of the 9 by 1 to 90 column, and each byte is made of the 8 bits. So its parity bytes and that user's byte will be 8 bits. So to calculate that STS1 data, so 8,000 will be my data, 9 will be my row of data, and 90 will be my column, and 8 bit, that in the one signal there will be 8 bit, and total is my 8,000 data signal. So my total data rate of the STS1 that will be should be 51.840 Mbps. If my STS1 link data rate will be 51.840, then that data will be sent. Otherwise, it will be not sent in that data link. If STS1 3 will be there, so it will be multiplied by 3. If STS 4 or 5, 6 will be, then this data will be multiplied with by 3, 4, 5, 6 into, and I'll multiply with that case in that case. So it will be multiplied in that case only there. So like that for STS 4 we multiply with the 4, for STS 16 we multiply with that 16. Okay, have you understand? So how calculate with the data rate with the different data? So what is the you mean by the synchronous and asynchronous? You tell me that synchronous optical network SDS is the synchronous digital hierarchy, like that full form. What is meaning of the synchronous and asynchronous?
The synchronous has same clockwise,
Synchronous means
whereas
simultaneous.
non-synchronous has
Concurrently.
induced.
Synchronous means we have to synchronize
Parallel.
we have to synchronize all the data in a single clock, same time period. Asynchronous means every data have a different time, so every data take the different time to reach their destinations. So we synchronize all the data in the same clock period. We have the single clock, and we synchronize that data in the single clock only that. So that's why this packet will be that user data will be saved in all the column, and through that single clock we send all the data on the single time period only that. That's why we synchronize all the data of the users, and then we have to transfer to the destination that through the optical fiber or that communication, that optical network. So I need your input for these both questions. It is wrong or match right? You can tell me your one answer on that. Arshita, what is the answer of the first questions? Namita and Jagannath?
Bus
I have given the four option. You have to choose.
star network.
Still star.
Okay.
Arshita is
Star network.
Arshita is star. Another? Namita is also star. Tell me.
And for the second one, it must be
So, have you any idea about this topology? Star, match, point to
yes,
point,
sir. Yes, sir. Yes, sir.
ring, tree.
So in ring network,
Yes, sir.
all the connecting devices are connected in the form of are it just like first device is connected to the other device in the form of ring. If the first one device will fail, then the all the communication will shut down. In the case of ring network.
So, in what happened in that case? In that, it will be. What is happening in this case? It will be also same. If I disconnected this will be not sent to that everyone. Any
Yes, sir.
node or bus will be that disconnected or destroyed.
Yes, sir.
So, Jagannath, second questions, your opinion? Arshita, are you there?
Yes, sir.
What is your opinion?
So mesh.
Star, sir. Star is single.
Second question is also star.
So I mesh.
So what do you want that if one need to set up an optical in an apartment like that, you have to live in any apartment that have the 7-story building or 8 building, or there is a like flat system is there, where the hub is located at the main reception area, from where connection to different building and different floor need to be carried out. Like that, I have that this my network or data center here, that, and
The
I want
first
to send
one,
this data. Like there is a library is there in the apartment, there is a gym in the apartment, here is a one flat, there is a 4 or 5 flat is there. This is the one building, there is a one building, where is a one building. You have to carry out that data to everyone. You want to identify that type of network you want to use, that which network you use to make the communication from that main area to these buildings.
Star.
So
Star network.
star will be like that.
Yes.
Okay.
sir.
So it will be
Okay.
possible without any failure, that star network will be helpful in this case.
Possible.
Huh?
Possible, sir.
So if this will be my failure, this network will be, this switch will be my destroy, or the power losses will be there, then the communication will be possible in that case. Or this will be disconnected, or this will be failure, this will be failure, because all are the interconnected in that case.
That is mesh, no, sir. Mesh.
Mesh will be like that.
Yeah.
So you want to use, you have to think about that. You need that from single point to multi-point communications. There is a one single point, you want to connect the multiple point with drop offs in between. Without any drops offs between that, there will be continuous carried out the signals. So we use that tree network in that case. In that case, why that this is the node for that tree, we have to divide that two node here and here. Then we have to again distribute this type of network. So this will be not failure, it have our auto backup, but this will be failure in that case, but only this line will be failure in that case. And we have to communicate all the like that, this building we have to like that. I have to erase. Who are living in the apartment like that 7-story building and 10, and anyone in the Bangalore or that Delhi, Noida, metro city? Like that, I have this building, I have building, I have the 4 flat, 6 or like that 8 flat. Another is building, big building. So what happened, this is my connection. I have one network will be there here, and again I have to make this network, this network, this network, this network. From this network I can again distribute like that cable that. This will be more efficient, and we can take the less path of that to travel the data to the users. So we have to calculate that shortest path to communicate it between that also, because if the path will be more to transmit the data, it will take the more time, bandwidth requirement is the more, losses will be in the more, in that case we need a coupler or that splicer in the more case. So first case we use the tree network. In second case, if you want to be fail proof, then we use that mesh network in that case. Okay, without that any fail proof, that like that there will be any fail in that. With fail means it will be fail in that case. But in the case of the mesh network, I want to send the signal to this network. From there to that I data there. This will be destroyed in that case. Then it will take the follow this path and this path also. It will follow this path and this path is also any failure. So maybe that if the shortest path will be a failure, and then it will take that whatever the other shortest path will be there in that case. So without failure we can use the mesh network in that case. Understand? What is happened that in the simple network, that in star, this is the star network, so it will be communicate through this, or it will directly come to this, and this is the fully connected mesh. This is the tree topology. So you use that tree topology in the first case, and this is the that Namita tell that ring that this will be if the destroy in the dead case, then we have to that because the data will be move in the one direction only in the ring, like that in the either in the clockwise or anti-clockwise. That if anything will be failure, any switch will be at outer or coupler will be failure, then the data will be not move in that case only. So this is the problem for you. You have to calculate, you have to given, you have to read that questions, and can you explain me that what questions want to tell? Anyone?
So we have to put the formula of link power budget so that it
Okay,
will calculate this question.
okay. So how you calculate? You have to given the two case. What is the OLN and ONU in optical? Optical link unit and that optical network unit. So you have to consider passive optical network that you shown in that that I have that one network is that here, that wavelength combiner, and two signal data. One is the that laser wavelength is a 310 nanometer source, and another is the 490, and another is the 1550 nanometer. So this is the data wavelength combiner, that optical passive network is there, and then we have that there is a splitter of that data, single feeder to fiber, and it will this multi-story building will be there. There is some coupler will be there, and to splice further that coupling that power and that signal will be there, and output side is the maybe the wavelength division multiplexing or TDM TWDM will be there in that case also. So you have to given that laser source 310 and 400 nanometer can be launched optical power of that 2 and 3 dB. So 310 optical PN is a 2 dB for that, there is a 2 dB in this case, and for that 4 nanometer it is a 3 dB into a fiber. The passive optical splitter is a 10 kilometer. So length of that optical splitter is the this from this source to that 10 kilometer. So length of that fiber will be 10 kilometer from that center office from here. The users are 5 kilometers from the power splitter. These users both all are 5 kilometers. Okay. The insertion loss are 3.5 and 64 dB for 1 into 6 coupler. There is a 1 into 6 coupler, so loss is the for that both the coupler that are you given. The fiber attenuation is a 0.6 dB per kilometer. For the simplicity, assume there is a no connection, splice or other loss in the link design. So you have to calculate how much the transmit upstream that through that center office, through that one to down upstream and downstream you have to calculate. How you calculate? So how much the total fiber loss will be there? If I want to calculate this path, first I take only this center office that I want to this calculate only for this. The total length of the fiber is my 15 kilometer. 10 is the from here and 5 here. And loss of that fiber is 0.6. So total loss is 15 into 0.06. How much it will be? 90 dB or 9 dB? Around 9 dB it will be.
90,
Okay?
90.
Yes. And for 1 into n star coupler, the splitting loss of the star coupler will be given that formula 10 log 1 by n. Okay? So how much will be loss in that case? You have to that given that 16, n will be there 16. So 1 kth will be 16. So its value will be multiplied with that 13.5 and another one multiply with that 30 by 2. It will multiply about from the 60.6 for that 310 and 410 nanometer for 1 and to 32 spiral. So you can calculate for both case that for 16 coupler that 13.5 that into that log 16 value you have to divide that it will become, and if you add both that total fiber loss and that uh, loss due to that 1 into 16 coupler, you have to got that questions for all the 4 questions for the upstream and downstream. Have you understand that? Any doubt in these questions? You got this type of question in the exam. Any assignment questions you want to explain from my side? You have any difficulty? Me and Jonik will be help you in that case. Jonik.
Yeah.
So from week 1 to week 12, any assignment questions you want to understand that? For week 12, if you have any doubt, Namita,
No,
Arshita,
sir.
have you go through that
English teaching me,
assignment?
sir.
Yes, sir.
Sir,
Yeah.
hello.
Yes, yes.
Sir, I have a doubt. I first want to ask from week 12, then I have doubt from the week 7 and 8 also.
Week 7 and 8 assignment.
Yes, sir. Some two questions I have, and I
Which?
have doubt in week 12.
Week 7, which questions? Which number? Can you show that questions or write to that chat box? Harshita, have you any doubt?
No, sir.
So how was the course? It is good, or have you learned something?
Yeah, sir, it's interesting, but I'm little confused about some weeks. But after solving assignments, I go through it, I completely understand.
So it will be beneficial for you.
Yes, of course, it is beneficial.
So live class will be help you, or that it will be just
Sir, it is the way of go through the topics again,
okay.
and we can raise doubts and we can clarify it.
So Jagannath, can you show me that questions?
So
7th and
question
8th.
number 4, sir. Question number 4 of the week 7, and I have doubt from week 12. Two questions.
Question number 4, that avalanche photodiode has a 65% quantum efficiency at 900 nanometer wavelength. A 0.5 microwatt incident power produces a multiplied photocurrent of 10 microwatt. Calculate the multiplication factor of the photodetector. That is questions. Hello.
Yes, sir. Yes, sir.
So you have to given the direct formula that photocurrent in the multiplication factor IP equal to multiplication factor into responsivity into power in. From that multiplication power you have to calculate IP upon RD into PN. So you have already given that power 0.5 microwatt, that photocurrent of 10 microampere, and responsivity you have to calculate that. From that quantum efficiency you have to given, so from that you can calculate the responsivity. RD formula you know that 1.24. Jagannath.
Yes, sir. Yes, sir.
From that you can calculate the multiplication
Yes,
factor in
yes,
that
sir,
case.
sir. Yes, sir. Yes, sir.
Another questions?
Yes, sir. From week 12, sir.
Week 12. Which? Which? Can you give a number of which question number? Questions number.
Question number, sir. I just read. Sir, this is question number 5, sir. Sorry, sir. Question number 4. Question number 4.
So you have to give in that
And
the
question number 10.
Sonnet system is available with ST3, STS40 and STS192. That one.
Yes, sir.
1 minute.
Asking about total data capacity.
Which actually I have also opening that assignment. Give me 1 minute. That Sonnet system is that data. Three Sonnet system are available at STS3, STS48 and STS192. Calculate how many 64 kbps voice channel can be carried out by each of three systems. That one that.
Yes, sir.
So STS data rate I have already calculate for STS1 that data rate. You have to understand that data rate how.
152.52 megabits per second.
What is?
152.52 megabits per second.
Okay. Okay. And you have to given that how many 64 kbs voice channel can be carried out by each of the three system. So total that data rate that like that 8000 signal we have to given that, now we have to given that 64 kbs of signal. So you have to give number of the voice channel. So that will be calculate that from that n equal to that STS data rate upon divide by the number of the signal that that voice signal, that number of the voice signal capacity. So STS rate for STS3 equal to 150.52, and you have to divide by the 64 kbps, and it is also in the mbps. You have to take care that unit also, that mbps and kbps. Okay, so if you divide that you can calculate the number of channels. Jagannath.
Yes, sir.
So
I am
if you divide that
understood.
data rate of the STS with that, because you want to that capacity of your data, that pocket or that data is the 64 kbps per second data rate send. and your data bandwidth of that STS1 or data band is 150.5 to Mbps and data in the kbps. So when you have to divide that, you have to take care of the Mbps and kbps. So either you calculate convert that m into 10 to the power 6 bt per second and kb 10 to the power 3 and divide, and then you have to solve that.
Okay, sir. Then, sir,
Okay.
last one, sir. 11 number, sir.
11. A cable television operator uses a optical bus, that one.
Yes, sir.
There is a that transmitter. There is a one tap, second tap, and third tap, and this is the users one. This is the users two. This is the users three. The distributed video signal to the subscriber. Each receiver need a minimum of 100 nanowatt to operate satisfactory. Optical tape couple 5% of power to each subscriber. Assume a 0.5 dB instantial loss for each tape coupler and 1 milliwatt transmitter bar. Find the number of the subscriber that could be added to the bus. So you have to calculate that loss and that everything that I think.
So like uh, you have to check how many more you can add. It's not just three.
I think that one formula. There is a direct formula like that, Jonik. I think that.
I don't know the direct formula.
That and madam have explained that like that.
A similar logic.
Nmn equal to like that minus 10 log 10 e, that coupling square e square minus 1 e, that how much that user will be there in that case. I think it will be solved through that.
Yeah, it's a same concept, but the power is launch power is given.
Okay.
How much loss can you incur? Like 0.5 dB per coupler,
So it will
and
minus alpha
also
L will be alpha will be that only that alpha into L that.
fiber loss is not given here.
So you have to calculate that dB into that 0.5 dB into that numerical value like that. Have you any idea that, Janak? Can you help me out, Janak?
For each coupler you add, each step coupler will give you 0.5 dB loss, and also at the last stop, you're taking 5% of that power out, and that 5% has to be 100 nanowatt. But I mean, is the question clear?
Jagannath, have you
Yeah,
understood?
you have to find an n basically. It's
Yes,
saying
sir.
user
Yes, sir.
number n,
I have an idea.
so you have to find n, and only thing varying in this question is just how many tap couplers there are, and you lose zero point 0.5 dB times n in the link, and launch 1 milliwatt, lose at each step, and at the last step you're only taking 5% power, which has to be 100 nanowatt minimum. That's all.
Any other doubt? Anything, or should we stop? Finish that our. Akansha, have you any doubt? You can write that chat box if you not able to unmute yourself and that. So, thank you everyone. It is very nice to interact with you that whole the class. I will enjoy so much and I have learned many things from you. Thank you, Jonek, for helping me out that for all the sessions. Thank you so much, Jonek, for that, for attending and that solved my problem and doubt.
Also,
So,
you helped a lot, sir.
I think admit card will be already that.
I don't know. I can ask the NPTEL team. I mean, exam is still okay. 2 weeks out. Okay.
So maybe next week you have to, maybe Monday or Tuesday you maybe get that. Maybe 2 weeks before I have read that guidelines that.
The solution for
Solution for?
eighth week not uploaded.
8 week not
Okay.
uploaded.
Yes, sir. From
Okay, I'll
9 to
check.
11. From 9 to 11 uploaded. Sir, 8 is not yet done.
Okay, I'll check.
Thank you.
So it's there, but it's in private still. Okay. I'll fix it. Okay.
Yes, sir, it is not available.
Yeah, I checked. It's showing private. I don't have access to make it public, so I'll ask them. They will do it.